Okay, so next week is going to be your first test in Math 112. The best way to review is going to be to do the practice test in ALEX. But I did just want to do a few examples to kind of help you as you're preparing for it. I just picked out some problems that are most commonly missed on the test, and I figured I would just run through those with you pretty quickly. Determining if an argument's valid. That tends to be a problematic area because it's so, it has so many steps to it, right? It's kind of complicated to do. So you set it up with, of course, the P and the Q. This top premise up here, that P implies Q, and then this bottom of P and Q, that conjunction. Then we're going to take the conjunction of the premises. And finally, to determine if the argument is valid, we're going to use this conjunction of the premises, implies the conclusion, and then look at that truth table column. If it's all T's, it's valid. If it's a mixture of T's and F's, or if it's all F's, then the argument's invalid. Now what I tend to do is, and you might have saw this in my notes for 112, that I get kind of lazy and I don't want to rewrite all of this over here, so I just kind of was like, okay, I'm just going to call that star, and then star implies P, just to make it a little easier what I have to write. Alright, so I thought you might want to take a second, just kind of take it all in. So we have P implies Q, that's the conditional statement, and remember that it is only false when the condition's met and the conclusion is not followed through on. So we have that true, false, true, true business. This is a conjunction, this is an and statement. It is only true when both of the premises are true, so true, true, boom. Otherwise, it is false. Now this one is the conjunction of the previous two columns. So you want to be really careful of where you're looking. So we're looking for that conjunction, that and, of these two columns. So I'm looking here and here. Remember that the conjunction is only true when both of them are true. So true, true, boom. Are they both true? Nope. Both true? Nope. Both true? Nope. And then lastly, to determine that validity, we have to take this column and do its conditional with the conclusion of the argument and look at that truth table. Now, here's what I didn't write. If I wanted to rewrite column P over here, I could, just so I have them side by side. So this column right here comes from doing the conditional statement of this column to P. So true to true is true. False to true, that's okay. False to false, that's okay. So this is just that conditional statement. The only time a conditional is false is when you have the true implies false. And we don't have that here. So this is all trues. That means our argument is valid. Now in ALEX, I know it will just give you pieces of the truth table. You certainly can add more columns in. Sorry, yawn. Or you can just write this down on paper. All right. So then after the test, you can always submit that paper into the D2L assignment folder and possibly get partial credit. So just keep that in mind. When it comes to the converse, the inverse, and the contrapositive of a statement, a lot of people get that one confused. So I just gave you a random statement. So P implies not Q. If we want to find the converse, you're going to flip the order. The inverse, you're going to negate both. The contrapositive, you're going to negate and flip. So the converse, you just flip the order. So P is first, P becomes second. Not Q was second, it becomes first. The inverse negates both. So that was P. If I negate it, boom, not P. If you negate a negation, you got to think of this as like two wrongs making a right, or a negative times a negative being a positive. So negating that makes it regular old Q. The contrapositive is a combination of the converse and the inverse. It's going to flip those and negate them. So this flips over here and changes from negated to not. This one flips over here and changes from, positive basically to negative. Now remember, you can have notes when you take the test. So if you find this stuff helpful, keep it nearby. Have any kind of formula sheets you've made for yourself, any kind of notes that you've taken, cheat sheets, anything like that. Have all that stuff together when you go to take the test. That way when you sit down to take it, you have all that stuff and you don't have to waste valuable time looking for it. Okay, so if we're talking about logically equivalent statements, so are the following logically equivalent, negations, or neither? So I'm talking about that or that. Logically equivalent means that they have exactly the same truth table column. Negations mean they have exactly opposite truth table columns, and neither means that, well, they're neither the same nor complete opposites. So we just need a truth table for both of those columns. So we've got P and Q. Now just like the order of operations, I'm going to do the parentheses first. Oh, sorry, I'm yawning because it's late. So I did that implication, that conditional statement. Remember, it's only false when you have the true-false combo here. This is then the negation of that previous column. So look, it's this column right here is just the opposite of this column. So look, opposite, 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 opposite. Then I have not P. This is the conjunction, or the and, of this column, this not P column, and excuse me, and this Q column. So I know they're kind of far apart, so you're going to want to watch those pretty closely. But it's an and the and is only true when both are true. So are they both true here and here? No. Here and here both true? Nope. Alright, sorry, I had to pause the video and step away so I could have a coughing fit that I thought was going to take me out. Alright, so we're doing this and for Q and not P. So both aren't true? Nope. Are both true? Nope. Both true? Yeah. Are both true? Nope. Now we look at the column for this one, which is right here, and then the column for this one, which is right here. Are they identical? No. Okay. Are they complete opposites of each other? Well, no, because this is the same, that one's opposite, but that one's the same. So they're neither exactly the same nor exact opposites. So we say that they are neither. Okay. Next up, let's talk about some set stuff. So, if you're looking at this very blurry little set for some reason here, it's amazing how that's in focus, but that is not. What is that? Fix that? Maybe a little bit. Alright. So if we're looking at this set right here, and you're asked to find this, remember this is the number. This is not asking for a Venn diagram. This is asking for the number or the cardinality. Okay? The cardinality of the intersection. The intersection is the overlap right here. So it's asking you not what elements are in there. The elements are 15, C, and 9. But how many things are in there? Well, 1, 2, 3. So we'd say that cardinality of that set is 3. The cardinality of the set that is not A and B. So the region that is not in A but is simultaneously in B is this region over here. You know, in ALEKS it'll give you the 1, 2, 3, 4, those Roman numerals. This answer would be that Roman numeral 3 right here. So it's 1, 2, 3, 4, 5. The region that is not in A unioned with not in B. Alright, so that's going to be the stuff that's not in A combined with the stuff that's not in B. So if you can imagine what that's going to look like, we've got everything outside of A and then everything outside of B. The only thing that gets left out of this union is this stuff right here. So the number of things in that set is going to be 12 because it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't count U. U is for the universe. That's not part of those things that are in the set. The number of things that are in the union of A and B, but then the complement of that union. Well, the union is everything inside circles A and or B. So the outside of that would be this outer area here. That cardinality is 3. There's 1, 2, 3 things in there. And this is asking for the number of things total in the universe. So that's anything inside of this entire rectangle, including inside the circles. A lot of people mistakenly think that the universe is just this outer part, and that's not true. The universe is everything inside here, including what's inside the circles. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 things. Let's do some more with some sets. So if we go back to the previous example, if you were asked to list the elements in those sets, set A, that list of elements, flip the page a little too soon on that, but the list of elements in A are 1, 8, A, 12, 15, C, and 9. Now remember, this is not the same thing as the cardinality. The cardinality just says how many things are in A, which is 1, 2, 3, 4, 5, 6, 7 things. So you want to make sure that you know the difference in those. That if you're asked to list the elements, you list them out individually with a comma. And you know ALEKS is super picky about this. It's going to ask you to put that little symbol for those curly braces. If you forget them, it's not a big deal. I will go through everybody's test and look for little things like that so I can change your partial credit to full credit if that's the only thing you missed. You know, if you're looking at the stuff that is not in B, so that's everything outside of circle B. So that would be E, 3, 4, 1, 8, A, 12. So there we go. Again, cardinality is the number of things in this set. So 1, 2, 3, 4, 5, 6, 7 things in that set. Okay, another topic that students tend to struggle with are equal and equivalent sets. Equal sets have exactly the same things, exactly the same elements, everything. Equivalent sets just have the same cardinality. They just have the same number of things. So if I'm looking at the sets 1, 2, 3, 4 and 10, 20, 30, 40, are these identical? Are they equal? No, they're not equal. But are they equivalent? Now the problem comes in everyday language that we tend to use these two words interchangeably. But mathematically, in this case, they're not the same. These two sets are equivalent because they have the same cardinality. They both have 4 elements in there. These two sets are equivalent. This one has one thing in it, is that word. This has one element in it. So they are equivalent. Now, if I take out those curly braces and just write this empty set by itself, now it means the empty set. Remember, if you put the empty set symbol inside braces, it no longer means the empty set. This is now a set with one thing in it. So this is a set with one element. This is a completely empty set. So they are not even equivalent. This has a cardinality of 0. This has a cardinality of 1. So what would two sets that are equal look like? Well, it could be two very identical sets, or if I just even rewrote the elements in a different order, that still counts as being equal. These sets still have the identical, the same identical elements inside of them. We very briefly talked about inductive and deductive reasoning. That was, what, in section like 1.1 or something? Inductive reasoning is just reasoning and reaching these conclusions based on just a few examples. Deductive reasoning is getting to a conclusion based on like rules, facts, data, or generally accepted knowledge. You know, so there's different types of reasonings, different ways that you're coming upon your conclusion. Are you doing so based on rules, facts, data, or are you coming, to this conclusion based on just like a few examples that you did? All right, and then lastly, more truth stuff, because I know how you guys feel about that stuff. Luckily, after this test, you will not see it again until the final, and even then it won't be very much. So is the following a tautology, a self-contradiction, or neither? Now, a tautology means that the final column is all true. A contradiction is all false. Neither is a mixture of truths and false. So we just need to build a truth table for this biconditional statement. So I'll start off my P and my Q. So then I've got a P and Q going on here. To build up to this one, I'm not going to go straight to this P implies not Q. I need a not Q first. Now, pay close attention for this one. This one is that conditional statement for P and not Q. So you really have to take out that middle stuff. So let me just grab a couple of highlighters here. I'm just going to cover them up so you can't see them. Alright, so I'm doing a conditional statement, an if-then statement, for this column to this column. Remember, these conditional statements are only false when the condition's met, but the conclusion's not followed through with. So, true, false. Otherwise, true, true, that's cool. False, false, that's cool. False, true, that's fine. Now we get this biconditional statement. And this is the biconditional statement that's going to go along with that. Oops, I'll just write on that. And that column. Now, a biconditional statement, remember, is only true when the truth values for these two columns are the same. So, looking at these two columns, are these the exact same truth value? No. Are these the same truth value? No. Are these the same truth value? No. Are these the same? No. Because this is a column of all falses, we say it's a self-contradiction or just a contradiction. So the question was, is it a tautology, a self-contradiction, or neither? So it's a self-contradiction. Or, sometimes we just abbreviate that and just say a contradiction. Okay, so like I said, make sure you do the practice test that is in Alex. Remember that after you do it, you can click on your grade and go in and look at what you missed and explanations of those. I'm always available via email if you need me, and please take advantage of that, because I don't want you guys to to end up with some questions between now and when the test opens. So, which is it's going to open on Monday. Alrighty, that's going to conclude this week's material.